Hello, I'm Kirke Borne, the Chief Science Officer at new startup DataPrime. The goal of DataPrime is to create a personalized job hunting experience for job candidates in the data professions, including data science, data engineering, cloud, and so much more. So providing that matchmaking service between the ideal candidate with the ideal employer. That's DataPrime. So I'm here today not to talk about that, but to talk about insights as a service at the edge with event science and an observability strategy. So here we go. One of my motivations for presenting this topic today is this recent poll. The results show the high level of dissatisfaction across organizations for their analytics results. And one of the reasons for the high level of dissatisfaction is the lack of value creation that they're getting from data that's moving faster than their business. So we're going to address how to keep up with the speed of data and how to produce that value and hence analytic satisfaction using event-driven architectures in our talk today. Our outline today covers these 4 topics: the preliminaries, having the talk, streaming data and event science, the Mars rover metaphor, which references back to my 20 years working at NASA, and data to value strategies with event-driven architectures. Here we go. Having the talk. We start the talk with the place where we should start the talk, which is defining what is our purpose. What is our North Star? What is our mission? Well, we are data professionals who are entrusted with our organization's massive digital and data assets. Our mission is to discover insights, to innovate, and to deliver value from data, and to provide leadership and to empower others in applications of data, including data scientists, data engineers, data analysts, and the broad community of data-literate and data-fluent employees. So apparently we're not doing a good job at this given the results of that poll we just saw a few minutes ago. So we're here today to address how we can amplify and accelerate analytics value from data using event-driven architectures. Having the talk also requires us to define the terminology we're using. And frequently people are confused by these terms, data science and machine learning, and maybe they should be because we tend to make them confusing, when in fact they're fairly simple. Data science is nothing more than the scientific process applied to discovery of insights in large data sets. So it's a scientific process and it's applied to the large data sets for discovery. And part of the process includes mathematics and coding. The mathematics is provided by machine learning, which is defined by the set of mathematical algorithms that learn from experience. So that basically means it's algorithms that learn patterns in data, historical data, that's what we mean by experience. And from those patterns, we're able to build advanced analytics models, including predictive analytics models. So understanding that these things are basically just looking at historical evidence, understanding it, and building predictions from it, it makes more sense to people than showing them a chart like the one you see on this slide with all these different algorithms listed here. So it's a scientific process looking for discoveries in data that help you build more value from your business from that evidence. Further clarification of what it is we're doing when we're having the talk is to say that machine learning and data science are really just about taking data to insights to business value. And that comes in these steps. First, discovering of patterns in data, pattern discovery. Then once we discover those patterns, do we see them again? How do we recognize them when they're there again? So pattern recognition. From pattern discovery and pattern recognition, we then take the next step to exploring the patterns that actually bring the most value to our business, pattern exploration. And then ultimately, pattern exploitation. That is actually making decisions and taking actions and monetizing the patterns that we find in our data sets. So this is what I just call the easy button around data analytics and data science and machine learning. Forget all those buzzwords. Just think of this. We're bringing data to action through insights, discovery, and data. When talking about pattern discovery, it would be natural for someone to say, what do you mean by patterns? Well, here's 4 broad categories of patterns we can discover in our data. And hopefully by the time it's described this way, people will realize data is not a four-letter word. And in fact, I know this is true because I've given public lectures to people who have absolutely no clue what AI, machine learning, data science is all about. And I describe it this way to them, along with a lot of other data literacy lessons I push them through. And at the end of the session, they say, wow, I've learned that data is not a four-letter word. So it wasn't the words out of my mouth, but out of their mouth that declared this. So anyone can use these types of understandings of patterns for business insights and value creation. So what are these patterns? Class discovery, correlation discovery, surprise discovery, and association or link discovery. So class discovery is about finding the groups, the categories, the population segments and segments of things in your data, including objects and people and events and behaviors. And not just learning the groups and the subgroups, but what are the rules that differentiate them, that uniquely distinguish them. Then correlation discovery. If you discover a trend that X trends with Y or X correlates with Y, you essentially have predictive power discovery. Because given X, you can find a Y. But what if that prediction is an outcome you don't like? What if you predict an outcome like an engine is going to fail, or an employee is going to leave, or your customer is going to take their business elsewhere? You make that prediction, you don't like it, can't you do something about it? Well, what you're saying is you want a prescriptive analytics model. Prescriptive analytics is a model where you learn the causal factors through all the additional dimensions, all the additional insights that you get from the extra dimensions of data and your data collection. Then you learn that some of those extra variables, those extra features, are causal variables. They're causal features. That is, you can cause the correlation to go up or down if you just adjust that parameter, if you just tune that parameter in the correct direction. So for example, if you want to increase customer sales or reduce risk, so you have this correlation, but you want to move it in one way or another, and finding those causal variables now gives you prescriptive power discovery, not just to have the outcome that's predicted, but to achieve an optimal, more desirable outcome. Number 3, I call surprise discovery, but often we call that outlier detection or anomaly detection. It's about finding this surprising, interesting, unexpected thing in data. And even a small child can do this. Everyone can understand if you say, find the thing that's different. Find the one that is different from everything else. That's a surprising discovery, and that could be a very insightful thing to discover in your data. And number 4 is association or link discovery. Finding the pattern of connections across your entire domain. Connect the dots that aren't connected. Sometimes that's called network science, sometimes it's called graph analytics, but it's finding those interesting associations and links across your domain that imply powerful things about those relationships. So graph analytics and graph models are probably the most powerful models and analytics in the data science world. We have just described 4 types of pattern discovery from data. But there's actually 5 dimensions of analytics of how you can apply those insights you've discovered from those patterns. And these 5 dimensions of analytics outcomes are described here. Going from descriptive analytics, which is hindsight, what happened, to diagnostic analytics, that is what's happening right now, which is oversight, to predictive analytics of what will happen, which is foresight, and beyond. So what's beyond? We already mentioned prescriptive analytics. Insights from data give us insights into what we can do to change an outcome that we predict, but we don't like what we predict. So prescriptive analytics is how you optimize an outcome based upon insights discovered in the data. So we've gone from hindsight to oversight to foresight to insight. And for something to rhyme with that, I came up with right sight. So cognitive analytics is the right sight. It's the 360 view. It's sort of the cognitive way that humans behave, taking in the full picture before you take an action. So the 360 view, where all the data informs the right decision and the right action in the right context. But beyond that, cognitive analytics is also representing the human cognitive ability of asking questions. Diagnostic and descriptive analytics are essentially answering questions that you already know to ask. But cognitive analytics is the opposite. It's answering questions or asking questions that you see in the data. The data informs the questions you should be asking. It allows you to generate questions, not just answers. So we're applying our analytics in all these different dimensions depending upon your business use case, but each one of these can be applied to those different types of pattern discovery we just referred to. Next, streaming data and event science. Well, I want to start with this pair of graphics here about the incoming explosive growth in Internet of Things and the industrial Internet of Things. Whether you measure it in dollars or you measure it in terms of deployments, its amazing growth is expected in the coming decade. In fact, there's a quote at the bottom of the slide I saw in a recent article that said, Internet of Things companies will dominate the 2020s. Is your resume ready? Well, I think we should all be prepared for not only this explosive growth of data, but the explosive growth in streaming data, and you definitely need some kind of platform or architecture to deal with it. So what's really interesting in the graph on the left, it shows two divergent curves beyond today. In the lower right portion of that graphic, you see sort of that orangey, pinky sort of curve, which talks about the number of network sensors and developers and sort of the developments that are happening in the sort of that space. But our space is really about business value creation. If we can maximize or amplify the business value creation from that set of resources, and we face it, we don't all have tons of money, right? So our resources aren't necessarily growing exponentially, but we can grow value exponentially from our resources when we realize that these event-driven architectures and platforms enable new business models, different kinds of business models. I'll talk about one at the end, talking about insights as a service, as a business model. But these multi-service endpoints, that is, data provides different insights to different aspects of the organization, whether it's customers or the market or your assets, asset tracking, asset performance, logistics, shipping, all these multi-service endpoints where you can access information, access insights. So the event-driven architecture and platform acts as a broker of all of these access points that give you insights across the business. And that way you're amplifying and accelerating and exponentially accelerating the business value you're creating from your limited resources while not necessarily increasing your expenditures or your resources exponentially, which is probably impossible. But if you do that, then you can be part of that revolution that's shown on the right side graphic, this exponential growth in revenue being brought on by this market. Unbelievable. Big, great year to be getting involved with this if you haven't got already, because the growth is just starting to take off big time. Here's a graphic that illustrates the sheer diversity and ubiquity of the Internet of Things. Sensors on all over the place, on almost anything, applied to smart cities and smart industry, smart homes, smart whatever. So I like to say the Internet used to be a thing, but as this slide illustrates, things are now the Internet. What all of those extra sensors give you is context. Context is other data about your data. Sometimes we call that metadata. But this other data powers those predictive and prescriptive analytics models I was talking about earlier. So you have these additional sensors that give you additional information, contextual information about whatever else you're monitoring through your sensors and through your data streams. So your event-driven architecture gives you the event, but you also can collect this contextual information to understand that event. What does it mean? How to react to it? How to address it? I'm not sure this was in the movie Toy Story, but I like to think it is. Context everywhere. Context to infinity and beyond. A real smart thing you can do with all of this streaming data coming through your event-driven architecture is to tag that data. Make it a knowledge carrier. That is, provide insights metadata insights, contextual data with the data stream. So the data stream might consist of billions of bytes, trillions of numbers, but if you can characterize sudden changes, sudden movements of the data, stationarity changes in the system you're monitoring, deviations, and maybe the mean, the variance, or the skew of the numbers in the data stream, tag those particular moments where that happened, then you can essentially characterize that entire billion numbers by just a handful of numbers, maybe a dozen or a few dozen numbers saying at this point something changed in this way, and then it was just perfectly fine to some other point where it changed in this other way. So these tags, these labels, are a way of data reduction. That is, you're reducing very large streams of numbers to just the actionable insights that are tagged and labeled in such a way that they become searchable and linkable and reusable in many other applications. So you're generating additional value. You're amplifying the value of these data in the data streams by making them reusable by other processes in your business. This contextual data of processes, events, and behaviors is brought about through smart meta tagging for insights discovery in these Internet of Things sequences and time series. So when I refer to Internet of Things, I refer to it as Internet of Context, but what it provides you is many different services. So this is part of that amplification I was talking to you about earlier. Those multi-service endpoints, access endpoints. You can have insights as a service. You can have forecasting as a service. For example, if a machine starts behaving in an unstrange manner, that's going to be an indicator that maybe it's going to fail. And you get context as a service because all the sensors in your environment tell you something about what's going on while other things are happening in your business. So context is just nothing more than what I would call metadata. It's just other data about your data. So there are multiple different applications of streaming sensor data. And you can get value from all these different applications of the same data stream. So context as a service, forecasting or insights as a service, those are business amplifiers of massive streaming data in those event-driven architectures. Next, we have the Mars rover metaphor. So this use case is a metaphor for your business where you're collecting data, collecting actionable insights from those data, in principle through an event-driven architecture where the events, that is the interesting insights that appear in the data, can trigger an action or trigger a decision or trigger some kind of activity in your business, that intelligent agent which is actionable from the data gathering, and it's done autonomously. That is, the data-informed journey informs APIs or processes that are enacted and instantiated when some particular event occurs. And so here's Percy, the Perseverance rover. Hopefully you've been watching Percy in the news this year, landing on Mars and its little helicopter flying around Mars. The whole goal of this is to bring data to information, then to knowledge, and ultimately to understanding and action. I like to think about this little Mars rover in this way. It's going from sensors to sentinels to sense. That is, it's collecting data from sensors. It's using algorithms which are like the sentinel, which is essentially like the guard on the guard post. The guard on the guard post says, hey, something is out there, something's coming, something is happening. Or it signals the all clear. So the sentinel is the set of machine learning algorithms that knows when to alert and when not to alert some specific kind of event in your data stream, in your business data stream. And then when you make sense of that through pattern recognition and pattern exploration, even pattern exploitation, you now know what the right action to take, the right decision to make based upon the sense you're making from the data stream, the events in the data stream that the sentinels alert you to. And so any application domain with streaming data can apply this metaphor to your business use case to bring the right action, the right decision at the right time through smart sentinels, which are again business rules that tell you when and when not to take an action, to raise an alert, to raise an alarm when you see some particular event in that data stream. So you can take that metaphor and apply it to any data to value strategy within your organization, specifically within an event-driven architecture. So I'll just be wrapping up with a few examples of ways and scorecards, if you want to think of it, of deriving value in the analytics value chain in that event-driven world that you live in. So one of these is I just mentioned, going from sensors to sentinels to cents, but ultimately to dollars and cents. Okay, so we're trying to create value both by productizing and monetizing your data streams. So this is an event-driven analytics value chain in 4 simple steps. But let's talk about it a little bit more technically than this. There's a concept which has been around for quite a few years called dynamic data-driven application systems. And this could just as easily be called dynamic event-driven application systems. And it has 4 steps, which are measurement, inference, prediction, and steering, the MIPS process. This process essentially starts with data collection, measurement, from any kind of sensor data in the world. And then there's the inference and predictions phase, which is the machine learning phase, where you observe from the data, but then you infer what it means. You devise a hypothesis of what this means, and then you predict an outcome based upon different choices that you might make. And after you optimize the outcome from that prediction, those set of predictions, then you actually take the action. You make the decision. You steer your resources in the right direction. So measurement is the data collection, inference and prediction is the machine learning steps, and the steering is the actionable part of your event-driven applications powered AI, gathering actionable insights from any streaming sensor data, automating any event-driven operational system. I was presenting this data-driven application systems concept at a conference once, and someone in the audience said to me, "Oh, that's just the OODA Loop." Turns out this guy was a jet fighter pilot for the Navy, and I said, "What's the OODA Loop?" And he said, "That's the military action and command decision process used by fighter pilots. And it was invented by a fighter pilot named John Boyd. And OODA stands for observe, orient, decide, and act." And after he said that to me and explained it to me, I realized that essentially is the same thing as this MIPS process. Because measurement is observe, inference is essentially the same as orient. That is, you infer what's going on in your environment. You sort of orient yourself in your environment. And prediction is essentially the same as a decision, right? Because essentially every decision is based upon a prediction of what the optimum outcome is. So you choose to take a particular action or make a particular decision based upon optimization of possible outcomes, and that's based on prediction. And then ultimately the last step is acting, steering your resources in direction. So from now on, I just want to call it the OODA Loop because it's not only cool sounding, it's actually a very good command decision-making process. I also put together the STELLAR Analytics Scorecard for data innovation and analytics mastery in your event-driven enterprise. So the word stellar is spelled by the first letter of these 7 things here, S-T-E-L-L-A-R. And they're written in a way to spell out the word stellar, which is why you see this, even though the numbering is not 1 through 7 evenly, but that's just because I wanted to spell the word. But in order, streaming data analytics. So you can achieve analytics mastery and demonstrate analytics mastery in your event-driven enterprise if you're working with streaming data to detect persons or behaviors of interest, points of interest, products of interest, any things interesting in your data, in that streaming data. Second thing you need to have on your team to be successful is team analytics, having this culture of experimentation, a diversified points of view and collaboration and data sharing, data reuse and data democratization. Then comes edge analytics. So look, edge analytics refers to locality in time. What's happening at the moment of data collection? Doing analytics to answer the question, what else is happening right now at this point in time? Then there's location analytics, which is location in geospace. That is what's happening at that place. Not only what's happening at this point in time, but what's happening at that place in that context. And then there's related entity analytics, number 5, which has to do with the location of this event or this behavior in feature space. So think about this as sort of the hyperdimensional space of your data. You got time, you got real space dimensions, and you got feature space. So what else is similar to this entity or to this behavior? So if you're doing edge, location, and related entity analytics on your events, you're going all the way into exploring all those high dimensional features of your data space that gives you both that predictive and prescriptive power. But you want to do this in an agile manner where you're building proofs of concept. You're thinking big but starting small. You're showing those value propositions or returning on investments are coming sufficiently fast that people will say, yeah, I see where you're going here. Let's keep going. And so you aim for the big thing, but you start with these small things to build those proofs of value. And through that process, you're failing fast to learn fast in order to improve your whole entire business. And that leads to number 7, which is the learning business system. So a learning system is nothing to do with training courses. It has to do with the system itself. Your entire business is actually data-driven, knowledge-driven. The business processes learn by continuous feedback from measurements in the system, which are embedded in the daily business practice. So a learning business system is an entire organization that learns and improves its practices through continuous improvement through measurement. So if you're doing these 7 steps in Stellar Analytics, you're achieving analytics mastery in your event-driven enterprise. And hopefully you're conquering the people in that poll who said that they're not achieving very much. They're very unsatisfied with how their company is doing in analytics. If you start doing these things, people will see the progress and the successes and specifically the satisfactory progress in analytics in your organization. So this leads us to this idea of observability. And it comes from event science. It says event science is much more than just monitoring with sensors and data. Because if you just deploy sensors everywhere, what you're basically guaranteeing is a data deluge. Ouch. You don't need more information. What you need is more insights. That's the truth. What you need is more insights. So consequently, your event-driven architecture needs to be smart. The deployments need to be smart. But how are they smart? Well, they're smart by being cognitive, contextual, and predictive. But also they're informed by deliberate decisions about where and when you need more insights in your enterprise. And they're also strategic, which means they're designed to meet desired outcomes and mission objectives. Therefore, you need a strategy, and that's what I call the observability strategy. It's a strategy that focuses on mission to get those insights where you need them, to deliver mission-critical insights as a service when and where you need them. So observability is different from monitoring. Some people will say to me, oh, isn't that just monitoring? And I say, no, monitoring is what you do. Sensors are how you do it. Observability is why you do it. Observability strategy answers the question, why are we doing this? Why are we collecting this data? Why are we putting these sensors here? You have that strategy. And the insights that you receive from those event data are the rewards for doing this. So you need to add some APIs to that, and then therefore you can start gaining context as a service, insights as a service, and even forecasting as a service. And in fact, this might be an entirely new business model, applying APIs to your sensors in your environment. Then any business unit or any business partner can access those insights through that API. And that can be part of your observability strategy. So in conclusion, the 3 analytic benefits of an event-driven architecture are these. Sentinel analytics, using the sensors and data to watch the things that should be watched to be assured that things are working fine. Or you could say, I'm picking up good vibrations. So this guarantees compliance and comfort that things are working well. Number 2, precursor analytics, that is start detecting those early warning signs of risky events. What are these changes and emerging trends in the data telling me? Is there something about to go wrong? Can I build a predictive or prescriptive model to understand and address these risks that I see coming? So those early warning signals, detect them through events with precursor analytics. And third, cognitive analytics. Discover the right questions you should ask. What questions should I be asking when I see something funny in my data? That's truly cognitive event science. So thank you. Come for the data, stay for the science. I'd like to close with this quote from Isaac Asimov, famous science writer, who said, "The most exciting phrase to hear in science, the one that heralds new discoveries, is not Eureka, but that's funny." So wishing you many funny encounters with your data. Thank you again. You can download the slides at the website shown here. Appreciate your attention today. Thank you.